Hello everyone, welcome to my channel. In this video, we'll learn about different annotations which is used for measurement of time or space complexity. So there are three types of annotation symbols used. One is big omega. The symbol is this one, omega, big omega, then theta and big O. So these three annotations or symbols are used for measuring or measurement of any unit. That unit can be time or space. So let's understand what does this big omega, big theta or big O means, and how they help us. Let's consider for any job. Let's the company is X company. It has mentioned that for 4 years candidate, we can give from 20 lakh to 40 lakh. So the company tells that the minimum will spend 20 lakh for any 4 years candidate, and maximum we can give 40 lakh. It's just an example. In that case, what is the best shot for the company to get the candidate of 4 years with 20 lakh? Because it's we can say cost saving for them. And at the worst case, they need to spend 40 lakh for the candidate. So, and in this case, from the company point of view, let's not think about the candidate point of view. This is the lower bound or a minimum salary the company is giving. So this one can be represented with omega. And the worst case scenario for the company is to pay 40 lakh, which is 10 times of the years of experience. So here we will say it is big O, worst case scenario. And let's say on an average in market, generally candidates take up to 30 lakh, or let's say they take 30 lakh for 4 years candidate. So average is 30 lakh. So this is, we can say, as theta annotation. So if we just create one function or try to represent the mathematical formula, it will be like the for company X, for 4 years candidates, company can give 5 times. It's like 5 times years of experience. So the best case scenario for the company, or lower bound, this is the known as lower bound or best case scenario. This is known as upper case or upper bound, and this is average. And always theta represents, or theta has, or we can say theta is sandwiched between lower bound and upper bound. That means theta represents both or both conditionals. So for 4 year candidates, the company is trying to can give 20 lakh as a base set. So we can say it's 5 times of the years of experience. So if we say years of experience is n, it's 5n is the omega. And worst case, upper bound is 40 lakh, that is 10 times. Let's say O is 10n. Actually, in another way, we can say it's and for theta, theta is not saying you that it will be 7.5 n. Theta tells that it is in between 5 n and 10 n. So it will lie in between. So that means for some condition, or we can say that there will be greater than and less than always. So in this case, this is the theta. So theta will tell that less than, means my theta. Generally, we will say theta is less than, and if we tell this is some another function, in that case, let's say it's g of n. It tells there will be some upper bound and some lower bound, where, and also it will be given that what is the value of n under what scenario it will be, some value will be less and some value will be more. So, in case of theta, always you will find this type of conditional or will be given, where this theta always represent the medium thing, or it is sandwich, we can say sandwich between lower and upper. Okay, this is we are saying some example from industry, but in algorithm world, can you give any example? Okay, let's think about binary search. Okay, in here we will not discuss regarding the implementation of binary search. That thing we can discuss later. There is another video for that. So in case of binary search tells that it performs with log n. Worst case is log n. That means it first goes to the middle of the element and try to find out the element. Let's say if we have some array like 1 2 3 4 5 6 7. So this is an array we have, and I want to find out, and if you can see that this is a sorted array. If we need to find out 4, whether 4 is there or not, and ideally 4 is the middle element. In this case, you will find that with let's say it's not 4, yeah, sorry 7, and then let's say it's 8. We have 8. So we need to find out 4. So it will go for the middle element, and it search middle element of this array is this 4. It found that 4 is available at this place. With one shot or with one search, it can find out. That means the time complexity is order of 1 if I want to find out 4. But if I want to search 1, in this case, binary search will first go for this pointer, then again it will go for this pointer, means a division of this, or by dividing, then again it will go for this pointer. So in that case, it is log of n. Log of 8 means 3 iteration is required. But best case we found that if we need to find out the middle element, then it figured out with first search when we are trying to search for 4. But in case of 1, it became log of n. So in this case, we can say the omega presentation. Omega is order of 1. Worst case is log n, and all other operations can perform between this. So why this big O is most important for the for any interview? Reason that big O considers about the worst scenario. So in case let's say you have got a very huge data set, in that case how your algorithm will perform. For that, the big O annotation is important because it takes care of a worst case. Although the omega tells our best set, but we are always worried about in best case scenario what will be the output of our algorithm. That's why in most of the interview question, whenever they ask about time complexity uh, or space complexity, in that case they ask you about big O annotation. Unless it is specified or mentioned that what is omega or theta, then always try to give answer or always give answer in terms of big O annotation. So it's like this: left side is lower bound, right side is upper bound, theta is sandwich or in between, which you can say average, or it's not average, it considers both upper bound and lower bound. It gives that mathematical expression with less than equal to, greater than equal to, all this. Oh, thank you.